edge designations, CFA level 1, pre-reading, quantitative methods, learning module 3, probability concepts. Just to give a bit of context to this particular video, remember what we spoke about a little bit earlier. All in all, there are 7 learning modules. Remember, the CFA have moved away from the concept of readings or chapters. They now call them learning modules, and all in all, for the quantitative method section of the pre-reads, okay, there are 7 learning modules. Let me just show you them very briefly, just to give a little bit of context to where we are in this particular video. Okay, learning module 1 was interest rates. Spoke about a little bit about present values and future values. Learning number 2 was all about, I'm just going to call it data. We spoke about organizing, visualizing, and describing data. Okay, there we saw standard deviations, means, variances, all that kind of good stuff. This particular learning module, number 3, is probability. Yeah, and it's a good one, of course. Okay, number 4 we'll start to deal with distributions. Okay, 5 is a little bit of sampling and estimation. Learning module 6, we start off looking at hypothesis testing, and learning number 7, module 7, is not really a learning module. Okay, it's an appendix. Okay, not an unimportant appendix, but an appendix notwithstanding, which deals with all the various tables that we use specifically as we move from learning module 2 all the way down to hypothesis testing. We're going to see the Z table, the T table, all the various tables that we work with. Those are all then contained in learning module 7, which in fact is an appendix. Okay, but let's get down to business, what we have to deal with today. Okay, learning module number 3, probability concepts. Okay, and as you can see on the very front page, we give you all what we call the LOSs, learning outcome statements, okay, for module 3. Okay, and there they are. What I always suggest to candidates, okay, in terms of, everyone says, well, why do you keep on reproducing these learning outcomes? Well, there's several reasons for that. Number 1, CFA International require us to do so as prep providers, so we do that, of course. But then as you go, and I'm going to just take you over here to the front page, or the next page, okay, of our notes, and you can see over there, we reproduce those learning outcome statements again in the notes, just to make sure that we put them in a nice orderly fashion. You can see where they sit. You can see what's required of you per each of these particular learning outcome statements. Let's get ourselves going straight away. We talk about probability concepts. Okay, learning module number 3. Okay, and we start off right on the bottom. Okay, and we start off and we talk about random variables, outcomes, and events. Okay, first and foremost, probability, and everybody knows what probability is. Probability is really the chance of something happening. In other words, if I had to say to you, what is the probability of there being rain today? I know the weather service typically gets it wrong, okay, but what is the probability of rain today? Oh, okay, well, 30%, 40%. And as we go through, we'll talk a little bit more about probabilities and how they work, okay, in terms of, when I talk about a probability, what are the rules of probabilities and good things like that. There's specific rules that we need to follow to be able to get that done. We'll talk about that more as we go through. Okay, some definitions. When I deal with probability, we deal with the following definitions. Number 1, a random experiment. Random experiment, why is it random? Of course, we know it's random because we don't know the results of that before we enter into the experiment. The result is not known in advance. The outcome, okay, the outcome is the result of my experience. For example, when I flip a coin, it's either going to be heads or tails. That's the outcome. And an event. An event is a group of one or more possible outcomes. Okay, and we're going to show you some of the notations as we go through. I don't want to focus too heavily on that. I want to make sure that we are familiar, okay, with our material over here, and not to overly focus, guys, too much on the formulas and how they're structured, but to give you a good sense of what's in them notwithstanding. Okay, let's get ourselves going, of course. But when we start off with the probabilities, guys, it's always important to remember there are two key rules behind probabilities. Probabilities always lie between 0 and 1. When we talk about 1, I'm just going to show you something now, okay, that is a little bit interesting. When we talk about probabilities, okay, 0 we know. 1, is everybody comfortable that 1 would also equal to, same thing as 100%. 1 is equal to 100%, same thing. Okay. And that's rule number 1. So your probabilities always, okay, fall between 0 and 1. You can't have a probability of 110%. Okay. In other words, it's always between 0 and 1 or 0 and 100%. That's rule number 1. We'll see the rules going as we go forward, but I just want to mention them now. So it falls between 0 and 100%. And rule number 2 is that when we sum all the probabilities together, they must equal to 100%. Now, what I mean by that, let's just say, for example, I said to you, what's the probability of rain? 30%. Then we know straight away, if probability summed to 100, if the probability of yes rain is 70%, well then yes, the probability of no rain is 1 minus that, which obviously will be 70%. But they always sum then to 1. Okay, let's have a quick look at an example over here. Let's suppose that we know that a certain share price has got a 40% chance of going up, 35% chance of going down, and 25% chance of the same. What can we say? Well, and this is just something, just one of the notations. As I said, I don't want to focus overly on them. Let's just get them clear, okay? But it's not, it doesn't deter our understanding. Look what I've done over there. The probability of a share price going up, this often confuses candidates. I've called that A. Why did I call that A? For absolutely no reason. Okay, it's important to know that I could have called that Z for all intents and purposes. Why did we call the share price dropping B? Doesn't matter. Again, I did because I did. No specific reason. And C, the same story. But now that I've done that, now we're going to say, what's the probability of A? But now I know what A is, don't I? I know that A is the probability of the share price going up. And I can say the probability of the share price going up is 40%. Is everybody comfortable? Is equal to 0.40. Now remember, all of this hinges upon what you decide to call a share price going up. You could have called it A, Z, G, whatever you decided to do. Does that make sense, guys? Okay. So, and then of course, the probability of B, and remember I defined B as the share price dropping. That's 35%. And I defined C as what? The share price stays the same, okay, and that's 25%, 0.25. What do you notice? Let's go through my two rules again. Rule number 1, all probabilities fall between 0 and 100. Yes, they do. Let's make my two rules there. Rule 1, rule 2. Is that less than 100%? Yes. Is that less? And is that less? Yes, they all fall below them. And if I sum them all together, what I get, guys? 1 or 100%. Yes, it satisfies rule number 2 as well. Okay, we move on. Okay, we talk about a random variable. What's a random variable? Okay, similar to a random experiment. Remember, a random experiment, it's random. We didn't know the result before we started. Okay, here we talk about a random variable. Okay, and remember, it's a random, it's a variable. The variable is something that will take on a value as we go forward. Okay, it's important to note that the outcome of a random variable, again, same story, okay, is we don't know it in advance. Okay, because remember, as I sit today, I don't know, will the share price go up, go down, or stay the same? Yes, once we finish the experiment one day later, well, then I know what's happened to the share price. And number 2, the probabilities of the relative outcome gives me a bit of an indication which is the most likely event to happen. Of course, if I take you back over here, well, we'll say, oh, hold on a second, it looks most likely that the share price will go up. Why? Because that's got the highest probability at 40% of all the probabilities. Okay. we move on. Okay, we start to talk now in the next learning outcome statement. Okay, we move on to mutually exclusive, and it's important that we get these definitions right up front, guys, because they will stand with us throughout the syllabus. Remember, we're in pre-read. Okay, and again, just to keep it in mind, guys, what does pre-read mean? Pre-read means that it is a part of the syllabus. CFA have taken out of the core syllabus, placed it into pre-read, telling us that no, it won't be specifically examined, but yes, you do need to know this before obviously you can move on to the core material. So yes, it does have a marked and important value for us. Let's get the definitions right up front. We talk about mutually exclusive, and look at the words, it's all in the words. Okay, and we'll look at an example in a second. Exclusive, okay, two or even more events are called mutually exclusive if they've got no outcomes in common. In other words, whatever outcome each of the events has, they are mutually exclusive. They can't have the same. Okay, we'll talk about that one in a second. Okay, and well, let's just briefly discuss it. So let's say, for example, my experiment, okay, is the flip of a coin. Now, we talk about the flipping of a coin. Okay, what are the outcomes? What are the outcomes? So, well, outcome number one and outcome number two. So if I flip a coin, outcome number one can be heads, outcome number two can be tails. Can you see? Then they can never be the same. Okay, they are called mutually exclusive. Okay, heads and tails are mutually exclusive. Okay, because when I toss the coin, I can't get. Okay, I can either get a heads or I can get a tails. Okay, they can't occur at the same time, unless you get some trickster who can manage to flip the coin directly in the middle somehow. Not likely. Okay, that's mutually exclusive. We come to our next term that I want you to be familiar with, which is called exhaustive. Okay, number one is two or more events will be defined as exhaustive if what? If they exhaust, okay, every possible outcome that is there that could possibly occur in the experiment. Okay, and let's have a look over here, and again, let's go back to my heads and tails experiment. Are the outcomes exhaustive? Yes, they are. Why? Because I know all the possible. What are the? If I just say to you up front, what are the possible outcomes with the flipping of a coin? You say, well, there are only two. It's heads or it's tails. In other words, they are exhaustive. We know what they all are. Okay, you can't say heads, tails, and many other solutions. No, heads and tails, they're exhaustive. That's all that they are. Same story over here. When I looked at my share price example previously, what did we say? A, share price can go up. B, share price can go down. And I think C was share price can stay the same. Those are mutually exclusive because the share price can only do one of those three things: up, down, or stay the same. And it's exhaustive. Yes, there are only three possible outcomes for my share price: up, down, or stay the same. I hope those concepts are clear. Okay, and I'm going to move on a little bit over here. Okay, we talk about our sample space. Okay, sample space, all of that means nice and simple, and don't get bogged down by the terminology. Okay, when we talk over here about a sample space, it's a list of all possible outcomes that can occur from our random experiment. We've seen that already before. Okay, and we've seen this part over here as well, properties of probabilities, and we know probabilities always lie between 0 and 1 inclusive, and my probabilities always sum to 1. We've seen all of these already. I'm not going to spend more time here. Okay, we've got different kinds of probabilities: empirical, subjective, and priori. Okay, and going back to my original example, which I spoke about right in the beginning, okay, we said, what is the probability of there being rain today? Well, let's say, I'll say 30%. Now the question is, well, that's nice, but how did you come up with the 30%? Who decided 30%? Where was that probability derived from? And now we come to our three major ways. Number one, okay, is empirical priority. probability, my apologies, okay, and it's empirical. Empirical means I've got some kind of a support from it, okay, a technique where past information is used to try and determine the future, okay. For example, we know that a certain team wins about half of their games. Well, then what would you say, and how do we know? Well, we look in the past. That's called empirical. I look backwards and I see, okay, yes, in fact, this team has won half of their games. So, well, I'm likely that they're going to win the next half of their games as well. And all that you do over there is you say, okay, well, if they won half their games now, good chance that they're going to win the next half of their games going forward. Again, we've got a little bit of a challenge with that. You say to yourself, okay, well, is that necessarily going to all be correct? Well, there we go. And we always begs the question, guys, always remember to ask the question with empirical, okay, is what happened in the past necessarily a good indicator of what's going to happen in the future? Ask the question. We've got what we call a priori probability. Priori means before or prior to, okay. So, but again, by way of example, we know that share prices of 30 of the top 50 companies went up yesterday prior to. Then what could you say? Okay, well, if 30 of the top 50 companies went up yesterday, okay, well, then we can say that what? 30 out of 50 is what, guys? 60%. Okay, there's a 60% chance, okay, that we're going to select a share whose price went up. If you just pick shares at random, okay, so you got 50 shares in front of you in a hat. You pick one out at random. What's the probability of that one share having gone up? What do we say? 60%. Why 60%? Because 30 of the top 50 companies yesterday went up a priori prior to. And then we've got subjective probability. Subjective is the least scientific of all. Subjective is hold on a second, and you ask the person, and he says, listen, why do you think that particular stock, is it going to go up or is it going to go down? He says, well, you know, that stock, I don't like it. I'm going to assign a probability of 70% of that stock losing value. So, but where'd you get to that from? No, it's subjective. I just feel it. And as you can see, guys, it's almost like a thing like a gut feel, and it's the least scientific, then, of course, of all of the approaches. Okay. We come out with an interesting concept, guys, as we move forward in terms of probabilities, and we talk about odds for and odds against a particular event. Okay, odds is a little bit of a subset of probabilities, okay, and it's a very similar concept, okay, but sometimes, and yes, from odds you can work out probabilities, and yes, from probabilities you can work out odds. But let me give you the formula over here, nice and simple. Okay, odds is equal to, okay, probability on the top. Is everybody comfortable with that? Okay, and on the bottom, 1 minus the probability. Okay, let's have a look at an example. Okay, but as you can see over here, if I've got odds, okay, I can work out probabilities. If I've got probabilities, I can work out odds. They're almost like what we would call a complementary, okay, event, one of the other. Let's go. Okay, let's have an example. It was always good to work with numbers. Assume I've got a full pack of 52 playing cards, okay, and I'm going to be drawing cards from my pack at random. Okay, what's the probability of me picking an ace? And what do we know about a pack of cards? We know that within a pack of cards there are 4 suits, okay, and within those 4 suits, okay, each one will contain an ace. So in total, there are 4 aces in the pack altogether. We know there are 52 playing cards altogether. So what's the probability of me getting an ace? 4 out of 52. And again, remember, you can make your definitions whatever you like. Here we're going to say probability of A, and you can see I've defined it over here. I'm calling A is my probability of getting an ace. So the P of A, the probability of getting an ace, is 4 out of 52. I haven't yet hit odds. I've only deal with probabilities. Okay, if that were so, okay, that's the probability of getting an ace. Okay, look at how we calculate odds. So odds will be 4 out of 52. Is everyone happy that that's my probability? So odds is equal to, remember, probability on the top over 1 minus probability on the bottom. Everyone comfortable with that? So everyone happy how I got 4 out of 52 on the top? My numerator is 4 out of 52. That's the probability of getting an ace. Everyone comfortable with that? Over 1 or 100% minus the probability of getting an ace, that equals to odds. Is everybody comfortable with that? Now, again, all you need to do is if they then give you probabilities, you can work out odds. If they give you odds, yes, you can work out probabilities as well. You just manipulate the equation in order to do so. But if you look over here, so my probability of getting an ace was 4 out of 52, also same thing as 1 out of 13. Is everybody comfortable? They're exactly the same numbers. Okay, and that's why we've moved from 4 out of 52 to 1 out of 13. Therefore, odds will then be equal to 1 over 12. Okay, just a different way of expressing it, but yes, one must know odds. Okay. Top of page 6, we come out to the next learning outcome statement, which talks about calculate and interpret conditional probabilities. Okay. First of all, we talk about we need to be able to be clear between the two kinds of probabilities: conditional probability and unconditional probability. Okay. Unconditional probability. Look at the words, and just guys, always think about it when you go through them. Don't overthink things. But we look over here, we're talking about probabilities, and this one is unconditional. It's not conditional upon anything. Okay. For example, okay, with this kind of probability, unconditional probability, generally just deals with one event only. It doesn't have to worry about what happens elsewhere. And the reason for that, of course, guys, it's not linked in any way. Okay. Let's go back to my share example that we looked at previously. Okay, that was the share price example. Those probabilities are unconditional. Okay, nothing else is taken into account when I do the calculation. Okay, we need to say, is that in fact a correct assumption? But we'll talk about that later. But just remember, unconditional, it's not linked. In other words, event A is not dependent on event B. B is not dependent on C. There's no linkage. They are all independent events completely. They are called unconditional probabilities. As opposed to, okay, conditional probabilities. And a conditional probability says that the probability of this event happening is conditional or takes into account the fact that some other event has occurred. Okay, and the fact that event A has already occurred or has not already occurred will greatly impact how my probabilities are going to look on event B. Okay, look at how we express that, by the way. Okay, it's P A B. Wow, let's talk about that briefly. This is called a conditional probability. A conditional probability says, what is the probability of what? Of A occurring, and remember, A will define as whatever we want it to be. What? Look at this. The line down means given that event B has already occurred. Can you see that? So that's called conditional. So it's the probability of A happening. What's my probability of A happening given that B has already occurred? Is everybody comfortable with that? Okay, so just remember there's the two kinds of probabilities. One is completely independent. That's called an unconditional probability. It stands on its own. It's not linked to anything happening before it. A conditional probability, yes, it's conditional upon something else happening. What's the probability of A happening, whatever A is, but what? Given that event B has already occurred. Okay. There's a few examples for you over there. Do take a look at some of those. Okay, there we go. I'm not going to spend too much more time on those because we're going to see them as we go forward. Let's go. Okay, we come to two different kinds of rules, okay? And this forms a little bit of the basis behind probability theories, and we need to talk about addition rules and multiplication rules as they apply to probabilities. Okay, the multiplication rule. Okay, the multiplication rule, and look at the words, you guys. You've got to really focus quite heavily. We've dealt with the definitions up until now. We've really got to focus on implementation of those right now. So the multiplication rule is a rule that allows us to link a conditional probability. Remember what's conditional? That the probability says, well, something else has happened before it, and a joint probability. We'll talk about that. Okay, so we've got both of those there together. We'll talk more about that. Here's your formula. Or that one. Wow, we're going to talk more about those. I just want to handle additional. I'm going to change color so we can keep them quite distinct. The addition rule talks about the probability of at least one of two events occurring. Look over here. Okay, this rule says, what is the probability of A happening or B? You see that? Okay, so the addition rule, we often refer to the addition rule as the OR rule. What's the probability of A occurring, whatever we define A as, or B? The multiplication rule is called the AND rule. Why is it called the AND rule? Because it's the probability of A and B happening, or the probability of A and B. They would change those formulas there for you. The addition rule says, no, I just want to know what's the probability of either one happening. Probability of A or B. Everyone happy with that? The total rule we'll talk about in a second. That's the next one that's coming. Okay, we don't want to overly confuse. But now I just want to talk about these two rules. Let's talk about the addition rule, okay, first. The addition rule says, all I want to know is what's the probability of one of the two events occurring. So can you see how I've defined that in my blue? The probability of A or B occurring. Okay, and what's that equal to? Well, let's see if it makes sense. So what's the probability of A or B occurring? Well, it's just equal to the probability of A plus the probability of B. I sum them together. Let's say, for example, and we'll look at an example in a second, but it's quite simple. It's the probability of A happening, so I'll take the probability of A, or B plus the probability of B. Look what we do next. I'm going to change my color here. I want you guys to fully understand this. Okay, minus the probability of A and B happening. Wow. Why do I do that last step? Okay, this last step over here. Why do I do that last step? Now, let's just think about this for a second. Let's just say, for example, I'm trying to work out what is the probability of me picking an ace. So let's say, for example, I define A as the probability of me picking an ace, and I define B as what's the probability of me picking one of the cards that are hearts. Is everybody comfortable with that? Okay, everyone comfortable with my example? So we know how many aces are there in my pack. Remembering again, guys, that in a pack of cards, there are 52 cards. Everyone comfortable? Everybody comfortable? What's the probability? Well, let's talk now. How many aces in the pack? 4. How many hearts? 13. Is everybody comfortable with that? So if I now had to say to you, listen, do me a favor. I want to know what's the probability of picking an ace, an A. Nice and easy. What's the probability of picking an ace, guys? 4 out of 52. Plus, what's the probability of picking a heart? Well, that's going to be 13 out of 52. Is everybody comfortable with that? But look what I need to minus, because remember, guys, there's going to be one card that's what? That is both an ace and a heart. So what am I doing with a minus? I'm saying minus the probability of picking that one card that's both an ace and a heart, because I've already accounted for that over there. Does that make sense, guys? Okay, because remember, it can't be both. So we say to ourselves, if I'm working within the addition rule, hold on a second, what's the probability of me picking an ace plus the probability of picking a heart? Well, an ace is 4 out of 52. There's my 4. The probability of picking a heart is 13 out of 52. But I've got to subtract the probability, because remember, there is one card in that pack that is both what? An ace and a heart. I've got to extract that from my probabilities. Okay, and by the way, I'll just show you that quick. What is that probability of it being an ace and a heart? Well, that's only 1 out of 52, because this is only one card, am I right, that is both an ace and a heart. Okay, hopefully you guys have got a bit of a sense then of the addition rule. We move back up. You think we're working a bit backwards today. Let's go. The multiplication rule. What does the multiplication rule say? The multiplication rule says, let's have a look. It says, it asks a different question of us. And it says, what's the probability of my card being an ace, and a heart? Well, we know the answer to that already, don't we? Because there's only one card in the entire pack that is both an ace and a heart. Okay, that we know already, don't we? Okay, good. But let's work out the maths anyway. Okay, and we ask ourselves the question, look at the formula over here, guys. Okay, the first part's easy. We're going to work a bit. What's the probability of an ace? Well, we know that by now. The probability of an ace is going to be 4 aces out of a total of 52 cards. Okay, this is formula number 1 or number 2, and you can look over here. They're exactly the same, but here it talks about probability of B. What's the probability of it being B, which is a heart, and we know that that's going to be 13 out of 52. You can use either one of these formulas. They're exactly the same. Okay. Formula 1 just works with the probability of B. As you can see that we're timesing by P of B. Formula 2 works with times P of A, the probability of it being an A. Can you even see how those work together? What's the difference? Well, if I'm working over here with the probability of it being A, I go the probability of B. What is the probability of it be given that what? I've already got an A. And over here, if I'm working with the probability of B, we ask ourselves the question, what's the probability of it being A given that I've already got a B? Let's just work with the one just to get an understanding of that. Let's look over here, guys. Okay. Everybody comfortable? We know the probability of A. What's the probability of me getting an ace? Well, we know we've got 52 cards. We know there's 4 aces. Is everybody comfortable that probability is 4 out of 52? But what does the first part ask us? It says to me, I want to know what's the probability of getting both an ace and a heart. Well, we say to ourselves, well, that is equal to the probability of getting a B, a heart. And what's the probability of me getting a heart, B, given that I've already got an ace? I've already got an ace. Given, you see, it's given A. So I've already got an ace in my hand. How many aces are there? We know there's 4. What's the probability of it being a heart? 1 out of 4. That's my probability. Everybody comfortable with that? Do you see how it works? So I hope everybody's seeing the given that rule. And I'm just going to go down here again just to illustrate that even more. So, and let's just look at that one more time just to make sure everybody's got it clear. Okay, the probability of it being, A and B. What do we know about A and B? The probability of it being A is the probability of it being an ace. The probability of it being B is the probability of it being a heart. Is everybody comfortable? What did we say? The probability of A and B. Okay, and we can pick any one of the 2 formulas. Makes no difference, guys. Can be that one. I'm just going to clean up over here. Okay, we can pick the first one. or you can pick the second one. Makes absolutely no difference. Let's work with the second one. It's nice and easy. They're the same, in fact. Okay, the probability of A and B is equal to the probability of B given A times the probability of A. Well, we know what's the probability of it being an ace. The probability of being an ace, we know there are 4 aces in the pack out of 52. Is everybody comfortable with that? So I can just plug and play that answer over there. Is everybody comfortable? Then I'll ask myself, what's the probability of B given A? Well, now let's with this requires a bit of thought. Okay, this requires just a little bit of thought, because we say to ourselves, okay, probability of B given that it's an ace. Well, how many aces are there in the pack? I know what's in my hand is what? It's an ace. How many aces in the pack? 4. What's the probability of it being B, a heart, given that it's an ace? Well, how many aces are there? 4. How many hearts are there? Ace of hearts? 1 out of 4. Is everybody comfortable? So this over here, PB of A is equal to 1 out of 4, because I know it's an ace already. What's the probability of it being a heart? 1 out of 4 times 4 out of 52, and we know times those all out, what do we get? It's in fact 1 out of 52, which is exactly right. What is the probability of picking a card, guys, out of a whole pack that is both an ace and a heart? We know that the probability is 1 out of 52. Okay, that's the multiplication. Hopefully I haven't gone too much into that, guys. Hopefully you've got an understanding of that. But we can see over here, guys, there are 2 formulas that you can use to calculate multiplication, rule 1 and 2. One rule that we've got, one formula, I'm just going to clean it up for you over here, for the addition rule. Okay, and that's over there. Okay, that's essentially your third one that you need to know, third formula. Total probability rule. The total probability rule says everything. Okay, and we're going to do that, the total probability rule. We'll talk about a formula in a second, but I'm going to just go through it by example first. Suppose we're doing a study on the number of people who visited America. We choose a random number of 100 people. In that group, there's 60 males and 40 females. Okay, now let's have a look over here. What do we know, of course, guys? That the events, male and female, are complementary. You can't be both. Okay, don't want to get controversial there, of course. Okay, and what do we know? That the probability of it being a male is 60 over 100. That would be the probability that of being a female being 40 over 100. Why do we know that? Because probabilities then sum to 1 or to 100%. What else do we know, guys? We also know over here that of the males, 50% say they've been to America, and of the females, 25% say they've been to America. Why is this called total probability? Because what have I got? I've got, in my grouping, I've got males, I've got females. I know 50% of the males went to America, visited, 25% of females went to America. I want what's called total probability. I want to know, guys, in total, what is the number of people? I don't care, males, females, anything like that. I just want to know what's the total number of people, guys, that have visited America. Can you see, guys? That's what we call the total rule. Okay, this is called, and that's why it's called total probability, because I'm going to just take you back over here. Total probability says what's the total, okay, people that have visited America, male, female, put them all together, sum them, do what you have to do. And look at the formula. I'm going to take you straight down to the formula over here. We know the numbers, don't we? Okay, let's have a look at the numbers. Simple. Can everybody see over here? There's a big plus. I'm going to take us down over here. And guys, I'm really working with this formula over here, which is called the total probability. I put a big plus in the middle. Okay, and we've got our we can put 2 brackets over there. What do we know? We know that 60% of the population are males, leaving me with 40% being females. How many males visited America? Times 25. 50% of males visited America. How many females visited America? 25%. Is everybody comfortable? When I sum that all together, I get to 0.40. What do we see? Okay, so 40% of the total group that I looked at has visited America. Can you see over here? The total probability rule is really just taking the two groupings together. In my particular example, 60% are males, 40% are females. And what do you notice about that, guys? Of course, those need to sum to 1. Then we say how many males visited, how many females visited, and then why is it called the total? Total, guys, means you sum them together. Everybody comfortable? So if we have to do a bit of revision where we are at this particular point in time, we have dealt with the multiplication rule. That's the AND rule. Sorry, that's the OR rule. Sorry, I'm getting myself a little bit confused over here. Let's just go back and make sure I show you this correctly. And don't confuse anybody, not including myself, of course. Okay. We start off with a multiplication rule. Multiplication rule says and. I want to know what's the probability of A and B happening. Addition rule says that's the OR rule. What's the probability of A or B happening? The total probability is the both rule. Okay, total. Okay, and we saw that via my example of what's the total probability of both males and females having visited, okay, America. Okay, hopefully that all makes a lot of sense to everybody. We move down a little bit over here, guys, top of page 9. We have a look at the two different kinds of events, and what you notice over here is that this is quite linked as we go through. There shouldn't be too much here that you haven't seen already, because now we're going to talk about two kinds of events. Independent, okay, and what does independent mean? The occurrence of one event does not affect the occurrence of the other. And what's the other one? Dependent. Dependent means, yes, they do have an impact one on each other. Okay, is everybody comfortable? So we've got the two different events that we talk about. Independent, they are completely de-linked one from the other. They're not linked at all. And dependent means that, yes, they are linked one to the other. Okay. And nice and simple over here, guys, and let's just have a look over here. Very simply, if the events are independent of each other, okay, well then they are independent of each other. I don't need to worry anything more about excluding anything from them. We'll look at an example in a second. Okay. And I'm going to talk about a little bit more about those as we go forward. Okay, let us move on just a little bit over here. And let's just say, for example, okay, and this is where I just wanted to show you, okay, the difference. Let's say, for example, I say to you, okay, what is the probability? Now, if they are, I'm talking about specifically, guys, that A and B are independent, they are not linked to each other. Okay, and I say to you guys, okay, the probability of A is Apple shares going up, and the probability of Apple shares going up today is 70%, and the probability of B is Tesla shares going up today, and that's 60%. Is everybody comfortable with my example? I'm working with, very important, guys, I'm working with independent. In other words, there are no links. There are no links between Apple shares going up and Tesla shares going up. They're not owned by the same people. No link at all. They are independent of each other. Now, if I have to say to you guys, hold on a second, because you've seen this one before. I want to know, I'm going to change my color now. I want to know what's the probability of A and B. Now, remember again, take us back over here. Probability of A and B is the AND rule. That's the multiplication rule. Everybody comfortable? And what did we do before? I want to show you this very carefully. Please, guys, make sure you are familiar with this. The probability of A and B. Okay. What did we say before? We said before it was what? That's the probability of B given A has already occurred times the probability of A. Didn't we say that before? turn a few pages back, you'll see that. But that was when they were dependent on each other. B was dependent upon A. Now I'm saying no, no, no. This is not the case of aces and hearts. They are not linked to each other in any way. This is just really, I'm going to clean up over here. This is when they are completely independent of each other. When they are completely independent, Apple shares, Tesla shares, what's the probability of A and B? The probability of Apple shares and Tesla shares both going up on the same day. Look at this calc, how easy. The probability of A, Apple shares going up, times the probability of B, Tesla shares going up at the same time. Okay, can you see the difference over here? Yes, it's also multiplication. Yes, it's also the AND rule. But important over here, these events are what? They are independent of each other. Beforehand, when I did exactly the same thing, let me just show you, let's just change color for you. And let me show you how it was before. It was probability of A and B. What did we say? That was equal to the probability of A given B times the probability of B. Because they're completely different equations. Why are they different? Here the two events are independent, and here there is a level of dependency. Can everyone see the difference? Okay. Okay. That's nice and simple. Hopefully that makes sense for everybody. Okay. We move on just a little bit over here. Okay, we talk about calculate and interpret an unconditional probability. And again, guys, you're going to see a lot of words, conditional, unconditional. Just make sure that you are familiar with them as you see them, and just break them down slowly. Calculate and interpret unconditional probability. In other words, the probabilities are not conditional upon each other, using the total probability rule. Okay, have you seen this before somewhere? Yeah. Okay, my US example, males and females. Okay, they're not linked to each other, and I'm using total probabilities, and we have seen that one before. I have to show you that example over there. Very little reason for me to do that again. Is everybody comfortable for that? Okay, so all we did over there was the total probability rule, and they were not then linked to each other. Okay. We move on to the very last one over here, nice and simple. Okay, nothing too crazy over here. On top of page 11, identify the most appropriate method to solve a particular counting problem. And we work with these things like factorials. If you've seen those on your calculator, it's this little fancy little button, the factorial button, which is that one. Okay. If you have a look on your calculator, I'm just trying to see if I can find it here for you. Then on my calculator, okay, we've got the various functions. It's the times button, okay, but of course you'll need to push second function of that particular button. Okay, and we look over here, guys, okay, and we're going to start off and talk about, okay, counting. Sounds nice and easy. Okay, let's have a look over here. Okay, suppose we're interested in 3 different types of shares: industrial shares, financial shares, technology shares. Okay, and let's say, for example, a certain stock exchange comprises 10 industrials, 8 financials, and 7 tech shares. Okay, we want our portfolio to comprise one of each share: 1 industrial share, 1 financial share, and 1 technology share. And the question asks us, how many different ways can these particular shares be chosen? Okay, it's a fairly simple calculation. Okay, we choose one of the 10 industrial shares. How many choices is that? Okay, 10 different choices. Okay, going to financial, again, we've got 8 different choices, and for technology shares, well, we've got 7 different choices. Okay, nice and simple calculation. Okay, how would we do the calc? You say 10 different choices for industrial, 8 different choices for financial, and 7 different choices then for technology. Total of 560 different choices. Everybody comfortable with that? Okay, we could also use this fancy concept called factorial. Okay, factorial is the product of successive numbers. Okay, let's say, for example, I go 5 factorial. What am I in fact saying, guys, with 5 factorial? I'm saying 5 times 4 times 3 times 2 times 1. 120. What am I saying when I go, say, example, 3 factorial? 3 factorial means 3 times 2 times 1 is equal to 6. Is everybody comfortable with that? Okay, so that's just another way of you being able to use that. Okay, and we've got another lovely example over here. Do take a look. Okay, we've got 5 people enter into a contest. Prize money for everybody. Okay, obviously the first guy gets the most, the 5th guy gets the least. Okay, and we say to ourselves, what are the different possibilities for first place? Because remember, you can only have one guy winning the first prize. Okay, and all you need to do is what are the different permutations of that. Nice and simple, guys. It's the answer is really just 5 factorial. 5 times 4 times 3 times 2 times 1. There are 120 different ways. Do take a look at some of the examples over there. We've got another example for you over there on what we call counting methods. Have a look at that particular one. We talk there about red, blue, and green balls. A similar concept, guys. Do take a look at that. These are the different permutations and methods that we use in terms of counting. Just have a look at those, make sure you are familiar with them. They are all then on your calculator. If you're looking on your calculator, to get all of these, guys, you are going to need your second function on your calculator, and it's the times, minus, and plus buttons then on your calculator. Okay, that then brings us to a conclusion of probabilities, guys. It's not crazily difficult reading, but it's not an easy reading either. What I do suggest, guys, is that you go over it a few times. You make sure that you can identify addition rule, multiplication rule, total rule. We talk about the differences between dependent and independent events. Some are linked, some are not linked. It does require perhaps 1 or 2 different watchings of this particular video just to make sure that you are familiar with all of the information contained therein. Remember, when you move away from here, from probabilities in the pre-read, we move to probabilities in the main read, okay, and then we go to things that are slightly more complicated, okay, and those are going to be things like Bayes theory and things like that will be coming up. Okay, top of page 14 over there, we give you a bit of a summary, okay, for learning module 3 probability concepts, and there's all of your information over there. Do take a look in the summary. We've given you a lovely table over here that deals with a general probability rule. We speak about odds. Remember, we spoke about odds. Then we go for multiplication, additional, and total rule. And then we've got the independent rule as well. If you can get all of those 6 cases of probabilities, I've given you examples, formulas, and calculations there. In the summary, you have got probabilities then nicely under your belt. Okay. And page 15 just concludes the summary with a few counting methods. This then brings us to a conclusion then of the pre-read for learning module number 3, probabilities.